Peace and long life. It's too bad I can't get a Matco dealer to stop here at least once a month or at least follow up on my orders. It doesn't seem to matter that he drives by the front door, has never met me, doesn't know who I am, doesn't know a thing about me except when he asked two Matco dealers local actually vouched for me. And he still flies by, I think, Tuesdays or sometime around 3 o'clock. Right by the front door. Yep, all he'd have to do is open up his... Literally, if he really wanted to, I could put a box in the driveway next to the mailbox. He could drive up, toss it out his driver window, into the box, and drive on. There's almost nothing that he sells on that truck that's that fragile that he couldn't drop the thing 4 or 5 feet. We drop stuff all the time in the shops. Anyway, this Matco light only has one fault. That magnet is poorly done. Yes, it's got a screw on there so you could put a bigger magnet, etc., but the magnet that's here is actually quite sufficient for most things, but it's not designed well. With the brass in there sticks up higher than what the magnets... Yeah. Magnets need contact, or at least firm contact, and not necessarily with a magnet, but they often put a cover on them. Well, if the brass is sticking below the cover, what's the point? Yeah, it's a screw-up. Probably they contracted to have this built. It's like everything else. Let's see where it's made. It's not saying where it's made. Well, that's a pain in the butt. Most likely China. I hope it's Taiwan. At least they're semi-capitalist. But life-wise, charging-wise, everything about it's pretty good. It would only last 4 hours if you put it on high. If you do it fast enough, you get a red doodad and a red blinker, and then you shut it off finally. If you turn it on, this one is actually very good. You can be, I think it said, no, that's right. What is it? This one's 6 hours and the other one's 2 hours, I think. Like, something. Obviously, I don't pay that much attention to it. But there, if it's on for any length of time, it'll immediately shut off. But if you want to select, that's when you just keep pushing until you get what you want or finally shut it off. This one for Snap-on is pretty good, but the problem they have is it's not much bigger in size than that. It charges well, and I think... What is this one? You have to... Irony, have to get another light. This one is just plain USB mini. This one's USB-C. And that seems to be a lot handier. Big old flat film LED Snap-on. The battery life of this is about 4 hours. They have a neat little meter on here. You turn it on, it tells you whether you have a full charge or not. While it's charging, the 4 little green dots in there will do their funky thing to tell you how much of a charge is in it. I think this one only lasts 3 hours or something on the full one, and I think it's some ridiculous 8 or 10 hours on flashlight. Main reason I have it anymore, or still keep it around, is the flashlight side is just doggone handy like an old-fashioned flashlight on both of these. This one in particular, though, because it only has 2 lights. There's no other setting. You either turn it on and use it, or you turn it off. It's not like that's it. And then when this won't even turn on until you're up here. Then it turns, you close it up and turns off. That's kind of a pain in the butt in one hand, but still shuts everything off for you. It's been a good light. The problem with this one is it has a very good magnet, but when you put things sideways, part of the problem is in its length. You lose leverage on your magnetic strength, especially when this thing is up. No, that's not that much weight, but it is leverage. So they both have their places. The Snap-on just plain has a better magnet. And as you can see, size-wise, they're similar in height, similar in width. So, similar in thickness, depth, and brightness. No, Matco, I think, has a little bit of an edge there. It's a little different type of LED. I gotta shut that all off now. Yes, I lost the cover on that side. I can't even remember, it rubbed against something and pulled the whole thing right out. I've been trying to put it back in, but it's too squishy. It's one of those that has a nub in it that's bigger than the hole, and you need to pull it through. You can't push it through very well. Well, anyway, what am I on here for today? Well, I'm going to put in the title, Supplemental Catalyst Reduction Systems. We had the conversation the other day when I said, SCR systems, and I was talking with a construction worker, actually construction company. Who was it? I'm talking to young Connor. C. Bryant Consulting. Come on, Connor. Consulting? C. Bryant, I move dirt. That one. Should have been C. If you're going to do it, C. Bryant Consulting. I move dirt, I cut wood. But he made it look cool, C. Bryant Consulting. Excavating and Forestry Services, LLC, Appalachian, New York. I never wanted to be an LLC. Timber harvesting, drainage, pond building, site work, driveways, land clearing, retaining walls. Relatively simple, one-horse operation so far. I don't think he's going to expand, but it's possible. He has some old friends that, it's the time of year they get laid off. And one person he talked about being laid off, I sat there and said, huh? But there isn't that much snow to clear, so he got laid off from a landscaping company, etc., etc. So, or is he no longer working? I can't remember how. The companies here, they'll be around for 10 years. Pff, gone. Just gone. Well, start another company, 10 years, pff, gone. Sometimes sooner, but usually it's 5 to 10 years. Out the door, go get another one. Unless they're an established brick and mortar business someplace, that's where they work, is at that facility, and only do road work occasionally, like repair shops, then that's a different story. They tend to hang around a little longer. But even then, there's a lot of them. They don't last longer than 10 years. Well, still, a supplemental catalyst reduction system. You can say catalytic or whatever, but it's the same idea. Supplemental, meaning they added it on. The government said, you will do this. Can I tell you something that's sick about all of this after treatment? All of this was decided under William Jefferson Pants Dropper Cigar Shoving Clinton in the 90s, his administration. It was started actually long before, from 76 to 80, with James Peanut Brain Moron Carter, one of the nastiest politicians in human. Don't tell me how wonderful he is because he builds houses. He's been a backbiter the entire time. He was vicious and still bitter till the day of his death that he didn't get his second term. Reagan came in and wiped everybody out. Reagan did originally what Trump had done his first time around. Walked all over the politicians, and the people voted for him. Yeah, that's how that works. We, the people, when we had a fair vote, chose what the politicians didn't like. Well, here we are. Catalytic converters, diesel particulate filters, regeneration systems, common rail. There's a lot of stuff in there that our federal government demanded because they were playing with it in Europe. And they paid people off. Literally. So then what's supplemental is that almost every system, every system does, that I've been familiar with over the last, 10 plus years, monkeying around with this at least. I think it goes back to 2010 when they started in with some of the DPF systems. There were some engines that they were able to use internal changes with the fuel injection and in the combustion chamber. That some of the engines back in the mid-2010s and earlier, mid-2000s and up, were able to avoid. Common rail came in pretty much in the 90s overseas, even before that. It's, believe it or not, an old concept. But it was a worthless concept to us over here without that fancy emission control. But as we were to find out later on, that the common rail system has a serious problem with basic longevity. The stuff can't take dirt. It's susceptible to anything. You have to have filters that are anywhere between 2 to 5 times more expensive. They're more prone to misfires with their injectors. Then you'll say, you don't know what oh, trust me. I've been through the Bosch pumps and the Denso pumps. I can't remember the name of the other company. Diesel Kiki. I've been through them. Been through the Kubota systems. Some Yanmar. Oops, my boy's sleeping over there. Jasper's not feeling good today. So I've been through all of those systems, and which isn't a lot, but at the same time, I'm working on them in the field mostly. And what it came down to was, what in the world do you people think you're doing? I mean, when you get down to it, the amount of waste that's attached to these systems is astronomical. We cleaned up the air, and you polluted everything else. You cleaned up the air in this little location, okay? Well, if we do that 1,000 times, yeah, but you polluted the air more, creating the systems to put on the engine to begin with, more than these systems will ever offset. It's insane. Porcelain that won't break down? Ceramics? Please. We'll crush it up and just do what with it? We'll put it into all the paved roads. Yeah, but you were the guys that telling us bituminous products are horrible. They're related to, that's right, crude oil. I mean, please. We're already putting other stuff in there, wasted rubber and tires and such. I mean, what are you going to do? Make more paved roads that you people on the left claim as part of your global warming problem? Well, it is in the cities. Well, there's nothing to offset it. Trees make shade. Trees absorb the heat. Trees and green grass do funny things. You know what they do? They absorb the heat and the sunlight and CO2 in the air. They filter it out. They make food for the tree. And the tree and the grass do funny things. They put out a waste product. It's called oxygen. It's terrible. Please. Something we were taught early on, and you guys on the left tried to change the mind, that green leafy things, well, they don't always. No, they don't. In the wintertime, they go dormant. And they put out CO2, put it up in the atmosphere. So the other parts of the planet that have trees that need CO2 and grass and green leafy things and food and other. Yeah. Wait a minute. Here in the cold climate, think about this. Here in the cold climate of the Northeast, which I've been here when it's been 30 below and 40 below, wind chills, and an honest 30 below zero occasionally. Very rare, but it happens. In my lifetime, since 1960, more than once. And when it gets cold, and the plants and trees go dormant, and they actually put out CO2. They're burning up their stored sugars. They do. In the cold climate, they put out CO2 that you people claim is global warming products. Really? Is it possible the trees are dormant? They're no longer putting off heat themselves or reflecting heat from the sun? No leaves to do that? Part of the reason why it's cold here? Other than less sunlight? Please. This is all a joke. Now, mind you, a common rail system properly set up, properly put together, properly filtered, and decent fuel, it runs well. It's controllable. Software program change, and therein again is another problem. Where's the reliability? You get some of them that last forever with good maintenance, and with good maintenance, you get those that just crap out. Tolerances are too tight. Cummins tried a hybrid system with their C-Series engines 8.3 with what they called the CAPS, Cummins Accumulator Pressure System. And it was kind of a way of bypassing the common rail. They're trying something of their own, but there was just too much in the tolerances and the materials and such that they didn't put enough investment into it to finish the research and development to get it to work. But it was quite the system. The engines started good. The governor response was good. Strong engines. But there was this huge, massive pump hanging off the timing gear case. I mean, almost bigger than a P7100 pump. In fact, in some respects, it was heavier. The Denso version of the P7100 is, like the 7100, they're aluminum. Put one up. It's just big and bulky. Well, this thing was a monstrosity and had a lot of steel in it. Why? Because in the pressure head, it was acting like an accumulator, much as a common rail. From the pressure head was what they call a rate-shaped tube that was designed to take the pulses from the head under certain pressures, and that acted like an expansion chamber, which was part of the rate-shape nature of it. Different tubes for different engines and different horsepower ranges. But the tube had so many vibrations in it, it broke often. too often. That alone was a problem. The distributor head, which it still had, would line up with the injector, but it wouldn't fire until the little pintle. They had one pintle running the whole system. The distributor head could have 20-some thousand pounds of pressure against it, so that would cause a problem. The distributor head had a little, I guess you call it a fuse shaft, where if there's too much stress in the distributor head from bad fuel or whatever, rather than destroy the entire pump or the head, it would snap that off. And we'd take the unit off and send it out to have it repaired, put a reman on, and go. That wasn't something we were doing in there because a lot of it had to be recalibrated. There was a lot of problems with that system, awful lot. But it did work. And one of the problems they had with the system was it had stored pressure, but it still operated like a jerk pump. When that pintle opened up, those lines had some residual pressure in them, but not much. And then there'd be a spike, just like the old jerk pump systems. Where your common rail, everything is charged. And the funny thing is, when you hit the injector, that line has a drop in pressure, albeit minuscule in time frame, probably 0.0001, but dink, and there it is. So that seemed to be less problematic once they got better lines than the cap system. Cap system depended on that one line to do all the work. They were trying to simplify rather than having 6 separate pintles and 6 separate lines out of the accumulator head. They were trying to simplify the system compared to your common rail. You say, well, the common rail is simple. Up to here it is. Then up top you have each individual cylinder has its own control solenoid and injector in one combination unit. Well, Cummins just put a poppet injector up there, just like an old system. So they're trying to make the old systems where they could just make some adjustments up here in the combustion chamber, maybe a different injector, but a poppet injector, a simple, inexpensive thing. And down here was where the money was. You know what the irony is? One of Cummins' best and most reliable systems that they build now, as far as hybrid system of theirs and Bosch combined in a common rail on the 8.9, the L9 series, that caps pump, they maintained it, put a different head on it as an accumulator head, and that feeds your common rail. This almost identical, it's different, it's obviously a different head, but it's almost an identical style system to the old caps. So what's that have to do with everything? Well, that's your control in the fuel system. But then it goes up into the catalytic converter, which is supposed to help with the NOx as well as a little bit of your particles. DPF captures the particles, but what's left over of the NOx, because up front it didn't catch a lot of it, but it caught enough in that first catalytic converter. Then it goes into the next in the DPF, and there's always probes on either end. Sometimes there's 3 probes in the system, and a lot of them only have 2 between the cat and the DPF. And at the end of the DPF, so they see what the heat is in the system, so the computer knows how to control what's going on with it, because there's up to 4 different cycles that thing runs. There is the usual running cycle that may get hot enough exhaust while the unit's working, so it's a passive system. Okay, then there's a secondary passive system, so to speak, where they start running through and maybe put a little bit of fuel, extra fuel in there from either a separate nozzle, or they'll do a third injection out of the injector in the engine and the exhaust, run it out through the exhaust, get the catalytic converter hot. When that gets hot, it sends superheated exhaust through your DPF and burns out the ash. So this one is just plain hot exhaust and the catalytic converter getting hotter. This one, they may or may not add a little bit of fuel, but they'll start cycling the system and playing with the turbo. And in some cases, like Deere, they have both an intake air flutter valve, throttle valve, and an exhaust with their turbo, the vanes. So they'll do controls there. But then you have the third system, which is pretty much stationary regeneration. And that's where they want you to park it. Because like here, it'll make some changes and put some fuel in, but that's you'll be going along. It'll say regen, and it'll be regenning while it's running. Okay? And then you have your stationary regen, where the operator parks it and hits the button and lets it go through its cycle. And that can go anywhere from 20 minutes to 2 hours, depending on what it sees and how far you let it go, or how far the machine itself let it go, which usually isn't that long. It'll be up to a half hour to an hour is pretty common. Sometimes you'll be lucky enough that in 15 minutes. So quite often they'll fire the machine up, put it in a safe place, and start the stationary regen and go to lunch or take a break and then come back later. So the first two, they'll run operationally. One of them is just natural heat. The other one is it'll create more heat one way or the other, whether fuel or vanes or whatever is required, because there might be just about enough heat from normal operation, but not quite, like during the summer. But in the wintertime, now we're up here. And then you get into your stationary regen, which you're going to see more in your fall, winter, and spring. Higher humidity, cooler temperatures. And then the last one is a service regen. Now, some of them say there's 4 as far as operation is concerned, because they split it up in natural operation. Then they'll go into passive operating regen, where they'll control the engine itself to get more heat through the catalytic converter in there. They'll take the third one as now it's starting to inject some fuel in to make the thing happen. And then they'll go into an operator stationary regen. And then they'll add the 5th one as your service regen, where the man comes in from either from their service shop or from the company, the sales company, or whoever's servicing the machine comes out, hooks up the computer, and starts the regen. Now with Komatsu, we did the regen service. We'd go into the service side of the controller and start that there. I've had to do that in some machines up to 3 times to burn out. Yeah, without ever taking it off. It'd be right up in the red, and we found a way to... Remember I said there's an operational regen, number 1, before you get to the... Okay. Number 1 is just general operation. Well, more than once I've gone out in excavators and started cycling and holding it, not just cycling, holding it. 30 seconds to a minute over relief, 30 seconds to a minute over relief, and try to do the different functions, tracks, everything. Lock it up and put the engine at the maximum amount of power that it would allow, and bring it right up to the PC or power control. And run the pump at that, and then keep moving it. One of the reasons to do it 30 seconds, you're up to the load point, maximum load point allowed by the controller. But when you're moving the lever in between the actual change of the pump, you hear the engine RPM go up, down, and then come back. Well, until it balances out the pressure for power control out of the engine, how much load is on it, in between is high flow while it's deciding that. So that's why you get the engine goes down as the hydraulic pressure and flow go up, and then they come back to a balance. Excuse me. So you'll hear that, and that's almost as important as just holding it over relief. I did that with one engine, I think, for 30 to 45 minutes, burned it out of the red, tried a regen, it wouldn't go, and then fired it up and ran it over again to take one red bar, yellow bar, and then I was able to do a couple of service regens to shut the machine off, restart it after each one, and then was able to put it into an operator regen. I think it's by the time I got done, I'd run it over relief for almost an hour and run it through for another hour and a half, 2 hours. I think I spent at least 3, possibly 4 hours on one of them, going through and burning it out in the field. Now, that's not something you can do on a bulldozer very easily because the torque converter gets too hot. But you need to find something hard to run it against because it's also in D rate. So it's harder. But it is possible. Loaders, maybe. Hydraulic doesn't put that much load on it, but you still can put a hydraulic load on and find a hill to climb. Or bury the bucket into something and drive it against the hydrostats on the smaller units. They'll have a temperature that you can watch. And make sure you don't exceed it into the yellow even. Just keep it down. Cycle it. Just keep cycling, working the hydraulics back and forth. Let the temperature come back down on the hydraulics, but keep working your engine. Your hydrostats are your hydraulics. Your transmission is separate, so that one you can continue to run the hydraulics while you let your transmission, you worked it and brought it up high in the range, and now all of a sudden you got to don't put it in neutral, drive the unit around slow and careful, and keep working your hydraulics. And hold it over 30 seconds each function. Just keep going. Of course, down is a little, not one to try, but run it down anyway because the hydraulics work. Bring it back up. Don't slam it. Be careful. Work the hydraulics. Just work it until you get it down. So those are some of the recommendations on that. And that gets your DPF clear. Now, your supplemental catalyst reduction system, that's something else altogether. That comes afterwards, and there's nothing you can really do to that because it does it automatically, but it calculates roughly how much nitrous oxide came through the system. And every one of these has, after your catalytic converter, your DPF, then there'll be a run of pipe, and in the pipe will be an injector just before another catalytic converter in the can for the SCR system. And it has 2 catalytic converters anymore. Farmers didn't used to have 2 in some of their systems. I've smelled the shops. They didn't have the second catalytic converter. Everything was happening from here to here. They spray the urea in the stream. That needs to be downstream far enough that the urea converts to ammonia. This is the bizarre part. The ammonia grabs a hold of the nitrogen, goes into the catalytic converter, and if they sprayed the correct amount in the stream, then it goes through the catalytic converter, first one, and it is a converter. It's a CAT. And then it does the exchange, supplemental catalyst reduction to reduce the NOx, comes into the chamber here, finishes it, and not all of the ammonia is captured and used. Well, it's a honeycomb system. You know, it's not perfect. Can't be. If you restrict the exhaust flow so bad, you'll cause the pollution you're trying to prevent. High heat causes the nitrogen oxide. But to get rid of the nitrous oxide, when it goes through, they have to make heat for everything. You get my drift? So the other one is often called a slip converter. So you have NOx coming in, the NOx sensor coming in, so it knows how much NOx it's collecting to fire its calculations in to shoot the urea in, go through the catalytic converter. And then on the outlet end, after the capture cat, because that does some of the NOx, but it's mainly to capture the ammonia, there will be both an ammonia sensor and a NOx sensor to know how much is coming out to make adjustments on what to do in between the in sensor and the injector, between there and the exit, to try and reduce the NOx and reduce the ammonia. And Garrett, let me tell you, they don't care so much about the ammonia. They just don't want people smelling it, because if they do, they know it's pollution, and ammonia is worse than any constituent in the exhaust stream coming out of the raw engine. This is the bizarre part of all of this. And this was demanded by the feds and the EPA. Somebody paid them off back in the 90s, possibly even the late 70s, that this stuff was all put in place. Because Caterpillar and others were fined and almost put out of business because they put in defeat programs where if the engine was going to destroy itself, that they would defeat the necessary after treatments and the engine operation carefully changed the level of power so that it didn't destroy the engine. Because that was in there, the feds went wild and fined everybody, except I think International, strangely enough, and Mercedes-Benz, I believe, was the other one. They let them go. Why? Well, apparently they did something different. Somehow they applied and got away with it. The claim was that they didn't have that D-rate system in there. Well, the other companies had a defeat function in there before the D-rate. That's what the claim is. And I watched enough Mercedes-Benz engines fail in John Deere haul trucks to like, oh, really? That's the best you can do? So the supplemental catalyst reduction system is an add-on. It's simply 2 more catalytic converters and urea sprayed in there to change to ammonia, to capture the NOx, to change its condition. It's not, now it changes it to something like nitrogen tetroxide or something, so it's not quite the acid causing rain and nitrogen. It's still nitrogen. You can't hardly change it, but it changes it enough that supposedly it's not bad up in the atmosphere. That's the claim. One guy in the system sat there from Dynapac. We were going to a service school for Dynapac equipment, and he says when they went to Tier 3, they did as much as you can, how did he say it? He did as much as you can legitimately do for emissions at Tier 3, which was your common rail system. Tier 2. Tier 1 was just smoke control on the turbo. which may have been smoke control on the turbo or an AFC, air fuel control, aneroid on the just fuel control to keep her from smoking. That's it, tier 1. Tier 2 is when they added common rail and some other fuel injection and combustion chamber changes. And there, quite a few companies were able to change things enough between the turbo and fuel system that the common rail wasn't necessary, plus the different horsepower ranges. There's a lot of companies that are able to get around. Awful lot right there. Tier 3, the government forced EGR systems, exhaust gas recirculating, to reduce, essentially, it took exhaust and dilute the intake to cut the combustion temperature down, to reduce NOx emissions because it comes at the peak. When you're putting on your horsepower and you're working like a dog, supposedly that high pressure, high heat is when it happens, so they try and drop that temperature, but they're still ramming all the air in there they can to produce the horsepower. What happens with all of this? Each step of the way from tier 1 to tier 2, tier 1 wasn't so bad because you were cutting fuel off, but still, the engine was allowed to smoke in general when it was working. It had to have enough turbo boost. So tier 1, tier 2 to tier 3, each step reduced actual total, reduced horsepower. So they had to work harder, and they actually burned more fuel per hour. That's correct. They put more fuel through the engine to cut the parts per million in the exhaust, but they put more total exhaust out of the engine. So it was a fantasy up to tier 3 with EGR. And some companies were able to get around the EGR, get their emissions without it. It's hard, but they found a way. No, it wasn't anything with cam timing or closing the exhaust valve. No, none of that. They just were able to do it within the combustion chamber. And their turbo, they changed something, and plus their horsepower ranges. And then from tier 1, your aneroid fuel control, then your tier 2, your common rail fuel systems, and now you're getting into tier 2 and tier 3, start getting into your turbochargers, your multi-vane variable geometry turbochargers, and your EGR systems, and then you go into your DPFs and catalysts. Some of the companies took tier 3, put a catalytic converter on them in a certain horsepower ranges, and they met emission standards that were thrown at them, arbitrarily thrown at them, with just a catalytic converter for tier 4, tier 4i, and tier 4 final. Well, introduction was, how can you say it? Introduction was they had to put the DPF on there. Tier 4 final for almost all of them was they would take a tier 3 engine, which may or may not have had a fancy, how can you say it? You got your CAT and your DPF put on your engine in tier 4 introduction. And it allowed them to, they went slightly higher standard by the end that they were supposed to meet. But it gave them time to get used to controlling the DPF, which everything affected that DPF. The catalytic converter, and especially that ceramic that was in there, was porous ceramic, was affected by the engine oil and the fuel both. So they had to change engine oils, they had to change fuel, even for the EGR, they had to change engine oil and fuel, so they had to change in another step for this. And by the time they got through the end of it, now they were on to tier 4 final, usually included the SCR systems if they were needed, which most commonly they were. Some companies like Deere put on their air fuel control, their aneroid fuel control in the beginning, then they went to their common rail systems, and some of them the next step with the EGR and or tier 4 introduction, they would put variable geometry turbocharger. John Deere made no changes from the original fuel system, just changed what they were doing in the first system and put it into the common rail system, and then went into their EGR systems, then went into their tier 4 systems. And tier 4 final, they would just added each system as it went along the way. In other words, from tier 1, they made no change of how much fuel was going through the engine to produce the power. They treated it as they went along and tried to maintain that same output from that engine. Well, obviously, you're putting crap on it all the way through, and you cannot do that. Now, tier 5, supposedly, they're going back into the combustion chambers and trying to streamline the DPF systems and the SCR systems, how far apart they were, where they were installed, to see how much more efficient they could make those systems with different internal components. But a lot of it was supposed to go back to the fuel injection, not necessarily, maybe higher pressure, and into the combustion chambers to make a more high swirl and to get more heat into the actual flame front to get it to burn up what it could. Yeah, I know, it would create more NOx emissions. So they were trying to create more heat without the peak. In other words, get closer and then have the treatment afterwards and reduce the exhaust back pressure. They're trying to outlaw the diesel engine. Now, we get through all of that, Tier 5, let's say it works. Now what have you got? You've got ceramics, catalytic converters with heavy metals in them, precious metals in them all the way through that you have to take care of. They claim they have processes, but now you take them, you have processes to recycle some of these heavy metals. Great. What does the process do to the environment as far as its impact? And no one is calculating that. They're just saying, we have this for the engine, we've got it with the engine. But they made an environmental disaster with everything else. Why? Because heat is needed to get these metals out of the catalytic converter. Just like processes, electricity, heat, and other things are needed for your lithium-ion batteries, to crunch them all up, to separate the chemicals. Come on, it takes energy. To support the process of emissions reductions in the engine is creating more pollution and environmental impact than the engine would if they'd just gotten up into Tier 2 where they were headed anyway, because of a more efficient engine that burns less fuel, puts out more power, and they have more control over the torque curve and horsepower curve of the engine. Are you kidding? That's what every customer wants, especially in the construction and farming industry. Seriously want. They were going there anyway. So I mandate something to force the companies to put something out and say, I made them do it before they were ready to do it. Ha ha. But they weren't ready to do it. The stuff wasn't finished in research and development to be finally put in the market. But market forces would have caused some of that anyway with some of the companies that were slightly behind and pushed them into doing it because somebody's out in front running ahead of you. They got it. Maybe. Yes, the free market would have done the same all the way across the board as everyone else ended up being demanded of by the government. Market forces. Well, they got fuel injection in cars, and they never would. Oh, trust me, they wanted fuel injection in those cars. It was simpler, much easier through production for them. Cleaner, easier, and much more control over it all. Are you kidding? The industry was going there. No, the carburetor guys, they sold. No, they bought off the old stuff with the carburetors. Fuel injection systems, please. Anything that they can charge more for and tell you that you're getting more bang for your dollar, they would have put that in those cars in a heartbeat anyway. Trust me on that one. Ford went for a while with a variable Venturi carburetor in several cars. They took a 302 engine and had that thing running the gas mileage of a V6 and the power of a 351 V8 in a 302 engine. They said until they wore out, that was the most astronomical function ever in a carburetor. Then they said it was, when it worked right, it was even better than fuel injection. The drivability was beyond crazy. But fuel injection won. Why? It's simpler. Much more reliable in general. Longevity was better. But then again, those variable Venturi carburetors didn't start causing much trouble until after 100,000 miles. I think your fuel injectors today are lasting 200. Yeah, we were going there anyway. Anything that would have kept a car out of warranty and had somebody bragging about it? Every time a car is sold to another owner, there's more money through the system for every single one of the vendors, as well as the original manufacturer quite often. So please. Then they wanted cars that they did in the 70s. They wanted you to buy another car. Of course they did. And then when they found out that, you know what, that's not what the people want. The Japs are killing us. Their cars last longer, and that's what people are buying. Suddenly we had better cars very rapidly. Please. If we can get the government out of our pockets and away from us, we will be better off. No more subsidized engine overhauls, no subsidized engine replacements, and all of that has to stop. If California wants to do it, let them do it. The rest of us don't need to. Let them subsidize their crap. And if it doesn't work for California, then the rest of us will sit back and say, it doesn't work. Let's not do that. What do they do over in Europe? One of the biggest things that people don't realize is Europeans are looking at us thinking we're absolutely insane. They're able to get their engines down to a point where they don't put out a whole lot of emissions on their own. And when they come out, they have a catalytic converter in their SCR systems, which still is stupid, but there's no DPF. And the DPFs are one of the most problematic parts of the entire system. So the reliability increased drastically with just a catalytic converter in the SCR. And if things were allowed to go in their normal pattern, I submit to you that the worst thing we ever would have had is a lifelong catalytic converter, unless something went wrong, like bad injectors or bad oil or an engine overheated, worn out. In other words, something catastrophic or near catastrophic happened, something critical or serious event happened to the engine to cause excess emissions to come out of it. But for the life of a well-maintained engine, a standard catalytic converter, by the time they got through with all the other adjustments, whether turbochargers, whether it needed an EGR or not, variable geometry cams and such, variable duration, variable time, and all of that, when they got through with all of that and their combustion chambers and injectors, I submit to you at this point that they very well may have only needed a catalytic converter to make all of this happy. Something that would have been easily cleaned and or easily replaced. And already has manufacturing, remanufacturing, and recycling processes built in the system compared to any of these others. Well, DPFs, the only way they're clean now is they take them back, and if you watch on YouTube and other places, DPF cleaning is almost done 100% with a garden hose. But then it's sent down into what? Either into somebody's leach field, out into somebody's gray water, or into a sewage treatment plant that isn't necessarily designed to handle that ash. It has to go somewhere. They can try and capture it. They're going to throw it in the landfill. Please. The pollution that didn't make it into the air, that's washed out with rain, by the way, over a much broader area so it'd have less effect, is most of it captured in that DPF. And when it's washed or recycled or anything else, the ash comes out. There is always pollution, no matter, even with a gas engine, there's always some form of pollution someplace that you can't capture. And if it is captured, you still have to do something with it. Catalytic converter on a gas engine? Yeah, maybe. But some of these, they're telling them they have to have 6. What's the environmental impact of creating 2, 4, and 6, 2, 3, and 4, and 6 catalytic converters? I've heard of as many as 8 on performance engines. Excuse me. What's just the manufacturing? What is the environmental impact of the manufacturing of these products just to stop some exhaust emissions that the atmosphere knows how to handle from volcanoes? Please. And they lied when they told us that the only chlorine atom from R12, that only R12 chlorine atom got up into the upper atmosphere and got the ozone. No. That was a blatant lie, and they knew it. So now what do you do? You folks have a good day. It's coming up on almost 44 minutes. If you've stuck with me this long, thank you very much. And remember, vote constructively for who the next president is, or who your representatives are. Somebody that at least talks like they have an idea of what humanity lives through each day. See ya.